Let's answer question 90. That is, we are given the height of the object as f of t equals negative t squared plus 15t minus 7. And we have to determine the instantaneous rate of change of the object at t equal to 10 seconds. So basically, this instantaneous rate of change of height of the object is f prime of t. So we'll find this f prime of t. This is basically the first derivative of the function f of t. So let's find the first derivative of f of t, and this equals, we have to differentiate each terms with respect to time. So differentiation of negative t squared with respect to t is, when we use the power rule, it becomes negative 2t, plus we have 15t. Differentiation of 15t is 15, and differentiation of t is 1. So it's basically differentiation of 15t is 15, and finally we have this negative 7, which is a constant. So differentiation of constant is 0. So this is the instantaneous rate of change function. Since we have to determine this instantaneous rate of change of object at t equal to 10 seconds, we have to plug in t equal to 10 into this equation. So therefore this becomes f prime of 10, and this equals negative 2 times of 10 plus 15. So this equals negative 2 times 10 is negative 20 plus 15. So this equals negative 20 plus 15 is negative 5, and the unit of this instantaneous rate of change of object is feet per second. So negative 5 feet per second is the instantaneous rate of change of object at t equal to 10 second, is the answer to this question. So you can choose the option 1. Let's answer question 91. In this question, we are given that the side of the square changes with the time, where x of t is given as 5t minus 2. We then have to find the formula for rate of change of area of the square. So let's do this. First, I'm going to write down the area formula of the square, which is a equals x of t quantity square. So this is basically using the area formula. That is, if S is the side of the square, we then say that the area of the square is A equals side square. Similarly, since x of t represents the side of the square, we can write down this area formula as A equals x of t quantity square. Now we have to differentiate this equation both sides with respect to time. So when we do that, we get dA over dt, and this is the rate of change of area of the square. And here on the right side, we have to apply the power rule to differentiate this x of t. So the power 2 comes in front, and we raise this x of t raised to the power of 2 minus 1 when we apply the power rule of differentiation. And we will also have to apply the chain rule to differentiate the x of t, that is d by dt of x of t. So this is the first step we write down here. Now let's substitute the values. Maybe I can simplify this. This is 2 minus 1 is 1. So I'm going to change this to just 1, or in fact, I can just keep it as it is. So it is 2 times of x of t multiplied by d by dt of x of t. Now I'm going to replace this x of t as 5t minus 2. So therefore, this becomes 2 times of 5t minus 2 multiplied with the differentiation of 5t minus 2. We then find the differentiation of 5t minus 2. So basically, this is the derivative of 5t minus 2. I can do it here. We have this expression. This could be split into two derivatives as d by dt of 5t minus d by dt of the constant 2. We know that derivative of 5t equals 5 times of derivative of t is just 1, and this 2 is a constant, so this becomes 0. So finally we get 5. 5 times 1 is 5. So the expression, that is, we can replace this as 5. Derivative of 5t minus 2 is 5. So therefore this becomes 2 times of 5t minus 2 times of 5. We then multiply the numbers, that is 5 times 2 is 10, and we get 10 times of 5t minus 2. So this is the final expression for the rate of change of area of the square, 10 times of 5t minus 2. And this means answer choice 3 is correct. In question 92, we find the rate of change of area of the circle. So if A represents the area of the circle, we write the formula for area of the circle as pi times of radius square. So we will find the derivative on both sides. So I'm going to find the derivative of A with respect to time, which is dA over dt. And similarly, on the right side also, we find the derivative with respect to time. So we get this expression like this. So let's simplify this. This pi is a constant, which means I can factor out the pi, and then I have to find the derivative of only the r squared. We then apply the power rule to find the derivative of r squared, and this becomes derivative of r square is when you apply the power rule, it is 2r, and then we have to apply the chain rule to find the derivative of r. So derivative of r with respect to time is dr over dt. Now let's replace r equal to t plus 3 as given in this problem. So therefore this becomes this is 2 pi, because pi times 2 is 2 pi, and radius is t plus 3, and we find the derivative of r with respect to time. So we can do it over here. This is r is given as t plus 3. We find the derivative on both sides, that is dr over dt. This equals the derivative of t is 1 and derivative of 3 is a constant. So this is it is 0. So therefore this is equivalent to 1. So dr by dt equals 1, which we can replace it over here. So finally this becomes 2 pi times of t plus 3. So this is the rate of change of area of the circle, that is dA over dt. This is dA over dt. And this means answer choice 3 is correct. In question 93, we have to find the rate of change of area of square when t equals 3 seconds, given that the side of the square x of t equals 4t minus 2. So let's find this. I'm going to write down the area formula for square, which is A equals x of t quantity square, where x of t is the side square. So we find the derivative both sides with respect to time. So derivative of A with respect to time is dA over dt, and this equals, here we have to apply the power rule to find the derivative of x of t. So when you apply the power rule, the 2 in comes in front, and we raise the power of x of t to 2 minus 1 like this. And we will also have to apply the chain rule to find the derivative of x of t. So we write down like this, t by dt of x of t. Now we can see that this is 2 minus 1 is basically 1. So you can just remove this, and this becomes 2 times of x of t times of d by dt of x of t. So first let's find this quantity d by dt of x of t. So for this I'm going to copy this x of t as given in this problem, which is x of t equals 4t minus 2. So which means we can find the derivative on both sides, that is d by dt of x of t. This is the derivative. So we find the derivative of 4t, which is 4, and derivative of 2 is a constant, so this becomes 0. So finally this is equal to 4. And this means we can replace it over here. This quantity equals 4. So therefore this becomes 2 times of, now replace the x of t as 4t minus 2. So this becomes 2 times of 4t minus 2 times of 4. So this equals 8 times of 4t minus 2. Basically, this is the expression for the rate of change of area of the square in terms of t. Now we have to answer that rate of change of area when t equals 3 seconds. And this means we can plug in t equal to 3 into this expression and find the value. So therefore, dA over dt when t equals 3 seconds, and this equals 8 times of, I replace t by 3. So therefore, this becomes 4 times of 3 minus 2, and this equals 8 times of 4 times of 3 is 12, and 12 minus 2 equals 10. So this quantity is 10, which becomes 8 times of 10, and this equals 80. We then have to put the unit as centimeter per second. So this is the rate of change of area of the square when t equal to 3 seconds, and this means option 3 is correct.